నిలుస్తున్న వైశ్య వికాస వేదిక సంయుక్త ఆధ్వర్యంలో విద్యార్థుల కొరకు మీ ముందుకు తీసుకురాబోతున్నారు స్టడీ బడి. వివిధ పోటీ పరీక్షలకు ప్రిపేర్ అవుతున్న విద్యార్థుల కోసం అపార అనుభవం గల ఫ్యాకల్టీలచే ఉచిత శిక్షణ మీకు అందుబాటులోకి రాబోతుంది. ఇందులో భాగంగా నీట్, జేఈఈ మరియు ఎంసెట్ ఎంట్రన్స్ కు జూన్ 29 నుంచి జూలై 31 వరకు ఫ్రీ కోచింగ్. స్టడీ బడి సోమవారం నుంచి శుక్రవారం వరకు మధ్యాహ్నం 3:30 నుండి సాయంత్రం 5:30 వరకు, తిరిగి సాయంత్రం 6 గంటల నుంచి 7 గంటల వరకు మీ
మీరు సొంత స్థలంలో ఇంటిని నిర్మించాలనుకుంటున్నారా? 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. అవునండి, మీరు విన్నది నిజమే. సన్షైన్ ఇన్ఫ్రాలో 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. టాప్ మోస్ట్ ఇంజనీర్స్, ఆర్కిటెక్ట్స్, మేస్త్రీల ఆధ్వర్యంలో ఇక నిశ్చింతగా మీ సొంత ఇంటిని కట్టుకోండి. సన్షైన్ ఇన్ఫ్రా బిల్డర్స్ అండ్ డెవలపర్స్.
స్టడీ బడి V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్. సమాజ హితమే లక్ష్యంగా దూసుకుపోతున్న V3 న్యూస్ సామాజిక సేవలో ఆదర్శంగా నిలుస్తున్న వైశ్య వికాస వేదిక సంయుక్త ఆధ్వర్యంలో విద్యార్థుల కొరకు మీ ముందుకు తీసుకురాబోతున్నారు స్టడీ బడి. వివిధ పోటీ పరీక్షలకు ప్రిపేర్ అవుతున్న విద్యార్థుల కోసం అపార అనుభవం గల ఫ్యాకల్టీలచే ఉచిత శిక్షణ మీకు అందుబాటులోకి రాబోతుంది. ఇందులో భాగంగా నీట్, జేఈఈ మరియు ఎంసెట్ ఎంట్రన్స్ కు జూన్ 29 నుంచి జూలై 31 వరకు ఫ్రీ కోచింగ్. స్టడీ బడి సోమవారం నుంచి శుక్రవారం వరకు మధ్యాహ్నం 3:30 నుండి సాయంత్రం 5:30 వరకు, తిరిగి సాయంత్రం 6 గంటల నుంచి 7 గంటల వరకు మీ V3 న్యూస్ ఛానల్లో.
మీరు సొంత స్థలంలో ఇంటిని నిర్మించాలనుకుంటున్నారా? 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. అవునండి, మీరు విన్నది నిజమే. సన్షైన్ ఇన్ఫ్రాలో 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. టాప్ మోస్ట్ ఇంజనీర్స్, ఆర్కిటెక్ట్స్, మేస్త్రీల ఆధ్వర్యంలో ఇక నిశ్చింతగా మీ సొంత ఇంటిని కట్టుకోండి. సన్షైన్ ఇన్ఫ్రా బిల్డర్స్ అండ్ డెవలపర్స్.
స్టడీ బడి V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్. సమాజ హితమే లక్ష్యంగా దూసుకుపోతున్న V3 న్యూస్ సామాజిక సేవలో ఆదర్శంగా నిలుస్తున్న వైశ్య వికాస వేదిక సంయుక్త ఆధ్వర్యంలో విద్యార్థుల కొరకు మీ ముందుకు తీసుకురాబోతున్నారు స్టడీ బడి. వివిధ పోటీ పరీక్షలకు ప్రిపేర్ అవుతున్న విద్యార్థుల కోసం అపార అనుభవం గల ఫ్యాకల్టీలచే ఉచిత శిక్షణ మీకు అందుబాటులోకి రాబోతుంది. ఇందులో భాగంగా నీట్, జేఈఈ మరియు ఎంసెట్ ఎంట్రన్స్ కు జూన్ 29 నుంచి జూలై 31 వరకు ఫ్రీ కోచింగ్. స్టడీ బడి సోమవారం నుంచి శుక్రవారం వరకు మధ్యాహ్నం 3:30 నుండి సాయంత్రం 5:30 వరకు, తిరిగి సాయంత్రం 6 గంటల నుంచి
మీరు సొంత స్థలంలో ఇంటిని నిర్మించాలనుకుంటున్నారా? 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. అవునండి, మీరు విన్నది నిజమే. సన్షైన్ ఇన్ఫ్రాలో 0% అడ్వాన్స్ సౌకర్యంతో మరియు కేవలం 1177 రూపాయలకే పూర్తి బిల్డింగ్ మెటీరియల్ తో ప్రారంభం. టాప్ మోస్ట్ ఇంజనీర్స్, ఆర్కిటెక్ట్స్, మేస్త్రీల ఆధ్వర్యంలో ఇక నిశ్చింతగా మీ సొంత ఇంటిని కట్టుకోండి. సన్షైన్ ఇన్ఫ్రా బిల్డర్స్ అండ్ డెవలపర్స్.
V3 న్యూస్ లక్ష్యం సమాజ హితం. V3 న్యూస్ లక్ష్యం సమాజ హితం.
స్టడీ బడి V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్ సమాజ హితమే లక్ష్యంగా దూసుకుపోతున్న V3 న్యూస్ సామాజిక సేవలో ఆదర్శంగా నిలుస్తున్న వైశ్య వికాస వేదిక సంయుక్త ఆధ్వర్యంలో విద్యార్థుల కొరకు మీ ముందుకు తీసుకురాబోతున్నారు స్టడీ బడి. వివిధ పోటీ పరీక్షలకు ప్రిపేర్ అవుతున్న విద్యార్థుల కోసం అపార అనుభవం గల
V3 న్యూస్ లక్ష్యం సమాజ హితం.
Good afternoon, dear students. Welcome to your V3 channel. In today's session of a class, let us try to discuss about some of the problems related to your spring and as well as of your block problems. Even in sometimes in work power energy, we will be asking us to calculate the effective spring constant when a block and as well as of your springs are being given. Like in SHM also, if you might have been seen, so many times we will be getting a problem in which we have a multiple springs and one single block. Whatever trick I am right now telling for you is right now it for one single block and for any number of your pulleys. It may be a 2 pulley, it may be a 2 pulley, it may be 3 pulley, it may be 4 pulley, and the springs can also be anything. It can be 1, it can be 2, it can be 3. Any number of your pulleys and any number of your springs is possible, but only the condition is that right now we will be having one single block system. So this tip and trick whichever I am trying to tell you right now is purely for one single block. So what are the basic steps right now in this one you see right now? Steps say for example steps to calculate effective spring constant and time period. Effective spring constant and time period. Okay, and applicable for single block system. Applicable only for a single block system. Applicable for a single block system. So whatever the tip or whatever the method I am trying to do it right now, it is only for a single block system right now. So point number 1 is right now what you do is whenever we have more than 2 pulleys or maybe a 2 springs part affiliation, cut the springs and connect them in the series combinations. So cut the springs and connect them in series combination. Connect them in your series combination. And second step is use the relation to K effective. K effective will be equal to is equals to K into your tension of your body by tension in the spring to the whole square. So TB is nothing but what for me? Tension in block. Tension in your block. TS is nothing but of your what? Tension in spring. Tension in your spring part affiliation. So that is the way how do we calculate the K effective part. So and finally if more than 2-3 springs are being given, you can calculate 1 by K effective is equals to 1 by your K1 plus 1 by your K2 plus 1 by your K3 plus so on for any number of your pulleys part affiliation. So this is a basic method by which we will be calculating the effective time period part affiliation or spring constant. So steps to calculate the effective spring constant and time period is, and it is applicable only for your single block system. The first step right now for me is cut the spring and connect them all of them in the series combination. Connect them in the series combination and use the formula K effective is equals to, what is the formula right now here? K effective is equals to your spring constant of that spring into tension of the body divided by tension of spring whole square. TB is nothing but what? Tension in the block. Ts is nothing but of your tension in the spring. If more than 2-3 springs are there, calculate the effective spring constant by the relation 1 by K effective is equals to 1 by K1 plus 1 by K2 plus 1 by K3, so on for the given condition part. I hope you are clear with this one. Okay, chalo. Let us try to do one problem based on this one right now. Say for example, I am giving you a question right now for this one. Say for example, I have got a system right now here. Okay, and there is a pulley right now here. This is your pulley, and there is your string right now, and this is connected to one more pulley, and this is passing through this relation, and there is one more pulley right now for this one right now. This string is passing through this one, so this pulley is right now here, and this is connected to this string, and there is a spring here right now of a spring constant, say for example of your K, and to this one there is a block which is been attached, a block of mass, say for example of your M. So, I need to calculate the K effective of this one. If I know how to calculate the K effective, I can also calculate the time period part of relation. I hope you know how to calculate this one right now. Let us first try to give the tensions for this one. Tension in the spring is right now for this one T in the upward direction, T in the downward direction. So, this one is also T and this one is also T. If this is T, this is T. In this one, this will become for me 2T. In this one, this will become 2T, and here it is also 2T, and here it is also your 2T part of relation. If this is 2T and this is 2T, here at the side will become for me 4T. This one is also your 4T. This total string is one single for me. So, here also it is 4T, and here it is also your 4T part. So, if it is 4T and 4T, the tension in this string will become for me how much? 80T, and here it will be your 80T part of relation right now. So, this is the way how do we are taking the tensions in each and every string part of relation. Here again I am trying to use the two methods to do the problem. Whichever you feel comfortable, you try to do it on your own. So, this is right now for me trick number 1. Okay, and this one is nothing but of your trick number 2. Whichever you feel comfortable, you try to use it. So, for both of them the result will be one and the same part of relation. The trick says for me right now here, K effective will be equal to K into your 2 to the power of your n whole square. 2 to the power of your n whole square part. Don't ask the derivation of that one. It is purely a trick to do the problem in the shortest way in the competitive examinations part of relation. So, what is the relation right now for me? K effective is equals to your K into 2 to the power of your n whole square. What is the n stands right now for me? N is equals to your number of your pulleys. N is equals to your number of your pulleys. You can use this relation right now. K effective is equals to K 2 to the power of your n whole square right now. How many pulleys are there right now? Better for me see 1, 2 and 3. Spring constant of this one is nothing but K. So, I can write here right now K effective is equals to your K into this one is 2 to the power of number of pulleys is right now how much for me? 3. That is nothing but of your whole square. So, that is nothing but of your K. So, this will be equal to how much? 2 cube is nothing but 4 is 8. This one is nothing but of your 8 square. So, 8 square is nothing but how much for me? 64. So, this one is 64 times of K. So, K effective is equals to 64 times of your K part of relation. Once I know the K effective, I can calculate even the time period for this one. Time period is calculated by the formula T is equals to 2 pi under root of your M by your K effective. M by your K effective part of relation. That means the answer comes out for me T is equals to, the answer come out for me this one, I am writing somewhere here right now. So, this will come for me T is equals to 2 pi under root of your, that this is nothing but of your mass M, because I have taken this one as of your capital M, divided by K effective. K effective is 64 times of your K part of relation. So, that is right now for me K effective. Isn't it? So, this will be your time period, and this is nothing but of your K effective. So, what is the first trick which I am using right now? K effective is equals to K 2 to the power of your n whole square, where n is nothing but for me number of your pulleys. If you are not comfortable with this one, you can even use this formula which I told you just now in the given condition. K effective is also equal to your, this formula you can use here, tension on the body divided by tension on the spring whole square. So, that is equals to your K into tension on the body. See, where is the body right now here? So, what is the tension on this body right now? 80T. So, this one is nothing but of your 80T divided by tension on the spring. On this spring, the tension is how much for me? Your capital T. So, this one is nothing but of your whole square. This T is given 8 into 8 is nothing but 64. So, this will come for me your 64 times of K. That means K effective is equals to 64 times of your K. So, even you can use this method to get the K effective part of a relation. So, I hope you got got an idea how to use this trick. Either you can use the trick number 1 or you can use your trick number 2, whichever you feel comfortable. Accordingly, you can apply and try to do the problems related to your multiple pulley. That means whenever you are seeing a problem where we have multiple pulleys and multiple springs and provided only one single block is been there, then for that one you can use this pulley. Again, see, when two blocks have been there, we have a general methods that will also try to do in the next session when I go for the next tip and trick when we have multiple blocks, multiple pulleys and multiple strings part of relation. So at that time we'll try to discuss how to do such type of a question. But in this session right now we are talking about only the situation where we are having a single block. I have written here also very clearly, this trick is applicable only for the single block system. So please don't try to use this trick for any other situation where we are having the multiple block. For that one also I'll tell you the method how to do the problems in the easiest way for the given condition. So what are the steps to do the problems I told you? Cut the spring and connect them in the series combination and use the formula K effective is equals to K into tension on the body divided by tension on the spring whole square, and 1 by K effective is equals to 1 by K1, 1 by K2, 1 by K3, go on part of a relation. This is a basic method or steps, or you can say a basic logic to use the problem. Even for this one you don't ask me derivation right now because we are not doing the regular class, so I can't go for the derivations of all this because this has been framed to do the problems in the shortest part of relation. So I hope you are clear with this problem. So if you are clear with this one, so we'll try to go for the one more problem related to the given condition. Okay, chalo. Chalo. So when I am rubbing, it might be consuming your time, so you can make it forward and try to listen the lecture whenever you feel comfortable. And please don't try to forget to download the app and try to subscribe the channel. So every day we'll be getting some new tips and tricks related to the topic in all the 4 subjects: mathematics, physics, chemistry, even in the bio part of relation. So I hope you will be enjoying the sections for all the 4. So let us try to go for the next session right now. That is nothing but one more problem. We'll try to do it out. Say for example, okay, if I give the problem something like this for you, okay, and here is your pulley, and here is your spring constant K, this is your pulley and this is your string, and here there is one more pulley and this is connected to your block here right now. Spring constant is also K. See, for the easy calculation in the short term, I am trying to take the spring constants to be the K. In the problem, in the numerical when he is giving for the examination, it can be K by 2, it can be K, it can be 3K, it can be 2K, that depends upon the examiner mind part of relation. So even here right now when I am doing the problem, you try to divide the problem into 2 parts right now beta. Up to here this is one part, you can apply the formula for this one. So how many pulleys are right now for this one? So K effective is equals to K effective is equals to K into your, I am using the formula 2 to the power of your n into your whole square, that is equals to K into your 2 to the power of how many pulleys? 1 pulley to whole square, so that will be equal to 4K. So K effective for this one, K effective for this one is how much I am getting? 4K part of relation. This is one. Or else you can use even the other trick which I told you right now. So if you are not comfortable with this one, you can use even this trick, that is K effective is equals to K into tension on the body divided by tension on the spring whole square, that is equals to K into tension on the body. Is there any tension on the body right now for me? No. So what I can use relative? So this trick I can't apply for this one. That is the reason I told you 2 equations right now for the given condition. So whenever you are using that conditions, you can use this relation directly. K effective is equals to K into 2 to the power of your n into your whole square part of relation, because we don't have a block at that time. So at that time the second formula applying is a little bit difficult. That is the reason you can use this formula directly. So K effective is equals to K into 2 to the power of your n into whole square. So K effective is equals to 4K, and what will be final effective, that is means K equivalent is equals to how much for me? Now see, this one in this one are right now in which combination beta? Parallel combination. So this will be in the parallel combination. They are side by side. So this will become for me how much? 4K plus this one will become for me your K. So the answer for this one is nothing but of your 5K. So the time period comes out for me T is equals to 2 pi under root of your m by K effective or K equivalent, whatever you write here. So it is nothing but of your K equivalent, that is equals to 2 pi under root of your m by this is nothing but of your 5K part of relation. So that is a way how do we get the problem answer for this question right now. But my answer or my condition is only to calculate the K equivalent for this one. So K equivalent for this one is coming out to be how much for me? Over 5K is your answer. I hope you are clear with this one. Even if the problem is something like this, now you try to take a paper and pen and try to do it with me in the shortest way. And the time I'm using right now, if you do it by the general method, it will take almost like 15 to 20 minutes to do such type of a problems if you are doing by the energy method part of relation. So I'm trying to make you do the same problem within the 30 seconds. If your calculation is very strong, you need not even write all the steps, you can do the answer like that in a fraction of a second. Now see here one more springs I'm taking right now, and here there is one more spring, and this is connected to these connections right now. And this one is say for example K, this one is say K, and this one is also your K. Now again find K effective is equals to your how much? For the question is right now for me, find K effective. Find for me here K effective is equals to how much? Even for this one up to here you make the formula to be applied right now. K effective comes out for me how much right now? K effective is equals to K into 2 to the power of again one single pulley to the fire. So the answer is equals to 4K. But these two pulleys are in which combination beta? Series combination. So when they are in the series combination, so when they are in this combination, these two are in which combination beta? They are in your series combination. They are in your series combination. When they are in the series combination, 1 by K effective is equals to your 1 by K1 plus of your 1 by K2. So K effective is equals to your K1 K2 divided by your K1 plus of your K2. Simply if you are being clear with the current electricity chapter, you can give me the answer in a second because both of them are same. So the answer will come out for me K by 2. So it is K into K. This one is nothing but of your K square divided by K plus K, that is nothing but 2K. So this one and this one will get cancelled. So the answer is nothing but of your K by 2. So K effective when they are connected in the series combination is how much? K by 2 part of relation. That means this spring block system will become somewhat me right now like this. This is the system right now. So this is your spring right now here. This is your spring pulley, this is connected to right now, and here is right now one single pulley. So it has become something like this right now, and here it is also fixed. So the spring constant of this one is nothing but K by 2, and this one is nothing but of your K part of relation. Now see, this both of them are in which combination beta? This both of them are in your parallel combination. They are in the parallel combination. So I can use the relation K equivalent is equals to your K effective plus of your in the series combination when you are taking right now parallel K by 2. That is nothing but of your 4K plus of your K by 2. That is equals to LCM is nothing but 2. 4 2 is 8. So it is nothing but of your 8K plus of your K. So that will be equal to your 9K by 2. So I can write here right now K equivalent is equals to 9K divided by your 2 part of relation. So time period for this one will become for me T is equals to 2 pi under root of your M by your K effective. So time period block is not given. So even if we are not talking about your time period, so leave it out. So K equivalent is equals to your 9K by your 2 will be the answer for the given question. So I hope you got an idea. Even whenever you see a system in where there is no block, only the pulley and the spring systems are being given, you can even try to use the simple method, simple shortcut, and try to get the answer for the given situation part of relations. I hope you are clear with this question also. So please copy it down. Let us try to go for the next question. Let us try to see this question, madam. Okay. So all the spring constants are given, say for example for me K. This one is K, this one is K, this one is K, and this one is also K. One block more than 2 pulleys, more than 2 springs part inflation. Even for this type of a questions, we can directly use the shortcut method which I told you. Let us first try to identify the tension. See here, the string which is connected to the block M passes to this pulley, it passes to the same pulley, it passes to the same pulley from here to here. So from here to here, this is one single wire. So when it is one single wire, you know that tension at each and every point will come out for me same. So here this is a tension T, here it is a tension T, here this one is your T, this one is also your T, this one is also 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 T, and this one is also T, because for one single string the tension at each and every point must be the same. Now see, if it is T, if it is T, 2T is acting in the downward direction. To balance it, 2T must be acting in the upward direction. So here on this one it will be 2T. So both of them will be balancing right now here. If it is T, if it is T, opposite force should also be your 2T part. So even here string and string, the tension in the spring must be equal to 2T in the downward direction, up is also a 2T. Here also it is nothing but of your 2T. T and T, here it is nothing but up is nothing but 2T, and down is also right now for me 2T. T and T, and here it comes out for me 2T, and upper is also coming out for me 2T part affiliation. So how many springs are right now told you? More than 2 springs are there. So I told you what is the first step right now in the doing. Cut the springs and connect all of them in the series combination. So I'll be cutting the total block, I'll connect all of the springs in the series combination. So before calculating the what do you call that one, connecting the series combination, let us try to calculate the effective spring constant for each and individual. Like say for example, if I am talking about this one as of your first case, this one as of your second case, this one as of your third case, and this one as of your fourth case. That means 4 K effectives I will be getting. So 1 by K effective or K equivalent I will write here. So K equivalent 1. K equivalent 1 is equals to how much? K equivalent 1 is equals to how much? That is nothing but equal to K into your tension on body. Tension on the body is nothing but T divided by tension on the spring. Tension on the spring is nothing but 2T whole square. That is nothing but how much for me? K by 4. So for this one, K equivalent 1 is how much for me? K by 4. In the same way, K equivalent to 2. If I am going for this one, even on the spring, the force is how much for me? 2T. Block is nothing but T. Again, we'll be getting the same answer. So I am not writing this step. The answer is same for me. K by your 4. Again, K equivalent of your 2. This is nothing but K equivalent of your 3 right now for this one. Again, the force on the spring is how much? 2T. On the block is nothing but of your T. So again, for this one is also how much for me? K by 4. K equivalent of your 3 if I am going. K equivalent of your 3. This is nothing but of your 4 right now. Sorry. So for this one also the spring. On the spring, the force is nothing but 2T. On the block, it is nothing but T. So again here it is nothing but K by 4. Now connect all of the springs in the series combination. So I will be getting right now 1 by K effective is equals to 1 by K equivalent 1 plus 1 by K equivalent to 2 plus 1 by K equivalent to 3 plus 1 by K equivalent to 4. So you know the values of K equivalent 1, you know the value of K equivalent to 2, 3 and 4. So from this one you can calculate the value of a K effective, you will get the answer for the given question part. Once you get the value of your K effective, you can use the formula T is equals to 2 pi under root of your M by K. This is of your M by K, this is nothing but K effective. Whatever the K effective you get it, you substitute, that will give me the time period part affiliation. So I hope this LCM part you can do it out, calculate the value of your K effective, pause the video. I hope that you will be subscribing the channel. After subscribing, please try to download the what you call that one app and try to calculate the value of K effective by pausing the lecture. After calculating the K effective, substitute in the formula, that will give me the answer for me. And please try to let me know the answer in the comment box, whatever the answer you are getting for the K effective and as well as of your time period part affiliation. Okay, chalo, take care beta, bye.
V3 న్యూస్ లక్ష్యం సమాజ హితం.
స్టడీ బడి V3 న్యూస్ స్మార్ట్ ఎడ్యుకేషన్. సమాజ హితమే లక్ష్యంగా దూసుకుపోతున్న V3 న్యూస్ సామాజిక సేవలో ఆదర్శంగా నిలుస్తున్న వైశ్య వికాస వేదిక సంయుక్త ఆధ్వర్యంలో విద్యార్థుల కొరకు మీ ముందుకు తీసుకురాబోతున్నారు స్టడీ బడి. వివిధ పోటీ పరీక్షలకు ప్రిపేర్ అవుతున్న విద్యార్థుల కోసం అపార అనుభవం గల ఫ్యాకల్టీలచే ఉచిత శిక్షణ మీకు అందుబాటులోకి రాబోతుంది. ఇందులో భాగంగా నీట్, జేఈఈ మరియు ఎంసెట్ ఎంట్రన్స్ కు జూన్ 29 నుంచి జూలై 31 వరకు ఫ్రీ కోచింగ్. స్టడీ బడి సోమవారం నుంచి శుక్రవారం వరకు మధ్యాహ్నం 3 గంటల 30 నిమిషాల నుండి సాయంత్రం 5 గంటల 30 నిమిషాల వరకు, తిరిగి సాయంత్రం